I've decided to work out these problems from the Chapter 4, 5 test because a lot of people had trouble with them. So I know problems like this will be on the final. Not the exact same problem, but something similar. So if you can do these, you should be able to do the ones on the final, that are from this category. There will be at least this many, too, of this type. So if you got the time, it wouldn't hurt to do them. All right, problem one from the test that I sent out to you should be the same as this one. It says, decide whether or not the ordered pair is a solution of the system being x plus y equals 4 and x minus y equals 2. So the way to do that is to stick those numbers in. You can do it in your head, 3 plus 1, 3 being the x and 1 being the y, equals 4, and then 3 minus 1 equals 2, so the answer would be yes. But you don't have to do it in your head. You could do it like this. X plus y equals 4. That's the first one. So we stick in the 3 is the x. So we'll put 3 in for x. We'll put the 1 in for y, because from our coordinates, 3, 1, right? And yes, they equal 4. So that's good in that one. It has to be good in both of them, though. The other one is x minus y equals 2. We'll put in the 3 for x. We'll minus whatever the y is, which is 1. And yes, 3 minus 1 is 2. So, oops, wrong one. The answer is yes. Number 2 on the test. Solve the system of equations graphically. We have x equals y minus 4 and 4x equals 2y. Okay, I like to always change these into the y equals mx plus b form to graph, and I think it's a good idea to get used to doing that. So we have x, we're on red, are we? X equals y minus 4. Okay, so let's add 4 to both sides, plus 4, plus 4. That's not showing up. There it is. Plus 4. Okay, so then we end up with 4 plus x equals y. Let's switch it around. We'll put the y on this side, and we'll put the 4 plus x on this side. Just like they change at quarters in the football game. So then we end up with y equals x plus 4. Okay, so our slope m equals 1. We'll make it a fraction 1 over 1. And our y-intercept equals 4. Okay. Well, there we go. There's our 4, and let's go up 1 over 1. There's there. Okay, so that's 1. We'll draw our line. Okay, then the other equation is 4x equals 2y. Divide both sides by 2, and we get y, that cancels, y equals 2x. Okay, again, I'm going to switch sides here. So y equals 2x. And then the intercept has to be 0. So we can have the plus 0. So our slope is 2, which is 2 over 1. And our intercept is 0. So let's plot the intercept. Oh, got it right on the nose. Then we'll do our next point where you count the slope. So we'll go up 2, 1, 2, and then over 1 to that spot right there. Okay, so graph it. And it's a little hard to tell on this one. If you do it with very carefully with a straight edge or ruler, you will cross at 4, 8. See, so now you you cross at that point and you think, well, I better make sure that's the right point. So stick in the 4 for 8. I mean the 4 for x. So 4 equals 8 minus 4. Yes, 4 equals 8 minus 4. 8 minus 4 is 4. So 4 equals 4. It works in that one. Put it in the second one. 4 times 4 is 16. See, 4 times x. 4 times 4 is 16. 2 times 8 is 16. So it works in that one. So that's the right point for 8. Alright, solve by the substitution method. This is number 4. We're skipping over number 3. And substitution, we're going to make one of the equations in terms of one of the variables. So we have x or y, we can choose. I choose this equation. That's the easiest one to work with, because you notice that x doesn't have a coefficient, nothing multiplying times the x in that equation. So it'll make it easy to deal with. So let's put that up here, see if I have room. X plus 4y equals negative 2. I'm not sure I do have room. Alright, so I'm going to add a negative 4y to both sides. Negative 4y, negative 4y. Add those in. My 4y's cancel out on this left side. So what I end up having is x equals a negative 4y minus 2. Okay, so now my other equation, that's the one I'm going to substitute this x in. But this x in this form, because this x equals this, right? So it's for us to be able to find that one point where the two lines cross, this x has to work in the other one. It has to. So we've got negative 4 times our new x plus 5y equals 8. Okay, so I'm going to stick this in that open spot. Negative 4y minus 2. I'm putting that in for x. Okay, so now we have to solve this. We have it all in one variable. Everything here is one variable. We just have y, so we're solving for y. Then we'll figure out what x is later. Okay, so we distribute the negative 4 I mean, over negative 4y and over negative 2. Negative 4 times negative 4y is a positive 16y. Negative 4 times negative 2 is a positive 8. And that's plus 5y, and that equals 8. Okay, let's subtract 8 from both sides. We'll get and then we'll add these two. We'll add these two together too. So 16y plus 5y is 21y. 21y, and then we have plus 8 minus 8 equals 8 minus 8. Okay, so you can see the 8's cancel out on both sides, leaving us with a 0 on this side and 21y equals 0. Divide both sides by 21, and these 21's cancel, and 21 into 0 is 0, so y equals 0. Alright, now we stick that back into the equation. If we stick it into the top equation, let me make some space here. We've got, we have x plus 4y equals negative 2. If I stick in 0 for y, we've got x plus 4 times 0 equals negative 2, which 4 times 0 is 0, so it's x equals negative 2. Now we just need to find out what y equals. So we'll stick the negative 2 back in for x, so negative 2 plus 4y equals negative 2. Alright, so we add 2 to both sides. Negative 2 plus 2 plus 4y equals negative 2 plus 2. 2's cancel out on both sides, giving us 0 plus 4y equals 0, or 4y equals 0 divided by 4 divided by 4, and our answer is y equals 0 also. Okay, so our answer is, x is negative 2 and y is 0. So now we've got to stick these back in our original equation. We might as well go all the way up here to do that. So if x is negative 2, we've got negative 2 plus 4 times 0, which is 0, equals negative 2. Alright, that works in that one. Alright, let's try in the other one. Okay, here we have negative 4 would be negative 4 times a negative 2 plus 5 times 0 equals 8. I'm running out of room, you can see. Alright, 4 times a negative 2 is a negative 8. The 5 times 0 is 0, so that's gone. Negative 8 equals negative 8. Did you hear me say that? That was wrong. Wrong, wrong, wrong. Okay, it was negative 4 times negative 2 is a positive 8. Positive 8, see? And that is a positive 8 over here. See, you notice in the original equation it's positive 8. Positive 8 equals positive 8. I'm not just fixing it so it'll work out. It actually does work out. Okay, anyway, you can do the math. You can see this is our answer. Try them in both equations. Make sure it works. Let's just check that again, because that was so messy. That's why I made a mistake. Okay, we've got x plus 4y equals negative 2. We're just going to test these points in that equation. So x is a negative 2. We have negative 2 plus 4 times y, which is 0, equals negative 2. 4 times 0 is 0, so we have negative 2 equals negative 2. Alright, then we've got negative 4x plus 5y equals 8. Negative 4 times negative 2 plus 5 times 0 equals 8. 5 times 0 is 0. Negative 4 times negative 2 is 8. So 8 equals 8. Yep, they both work. See, you notice. Negative 2 equals negative 2. 8 equals 8. They come out to be true. If they're true, it works. Alright, number 5. Solve using the elimination method. So we have these two equations, x plus y equals negative 2 and x minus y equals negative 4. And what we do is we add both equations together, straight up and down. The reason we can do that is because this side equals this side. So I can add them. Add the bottom equation to the top equation, and it doesn't change it because both sides are equal. It's like adding 3 to one side and 3 to the other side. Or in this case, negative 4 to one side and negative 4 to the other side. Okay? So let's do it. Okay, x plus x is 2x. So I'm adding all these together. Okay. Positive y plus a negative y, they're opposites, so it's 0. That's 0. And negative 2 plus a negative 4 is a negative 6. Alright, so we have 2x equals negative 6. Divide by 2. Notice we just have one variable now. Divide by 2. X equals a negative 3. Then we stick it back in the equation. Negative 3 for x. So we'll start with this equation. Negative 3 plus y equals negative 2. Alright, I'll add 3 to both sides. and we get these, this side cancels, and we get y equals 1. Okay, so our ordered pair is -3, 1. We try it in the equations. Our two equations, x plus y equals -2. Stick a -3 in for x, 1 in for y. -3 plus 1 equals a -2. -2 equals -2. Works. Okay, let's try it in the other one. The other equation is x minus y equals -4. Let's see if it works here. -3 is our x, minus whatever the y is, which is 1. Does that equal -4? -3 plus a -1 or minus 1 is a -4. So -4 equals -4. Yes, it works. So that is the answer through elimination. Sometimes, though, you have to change one of the equations. So when you add them together, one of the variables, either the x or the y, cancels out. Notice if we add these two equations together, 2x plus 3y equals -2 and x minus y equals -6. If we add those together, we're going to still have x's and y's. We're going to end up with like 3x plus 2y equals -8. That doesn't help us a bit. So we've got to change one of the equations. In this case, the easiest thing to change is the second equation, because it's just x minus y. And we could either multiply them both by 3, and then the 3y and the -3y we would get will cancel out, or we can multiply them both by -2, in which case the 2x and the -2x will cancel. And that's what I'm going to do. I like that idea the best. But you know, you do what's easiest for you. So, -2 times this side, and a -2 times this side. Okay, so I get a -2x positive 2y equals a positive 12. All right, I'm going to add it to the first equation, right? That one. So I'll add that in there. I'm going to rewrite it. 2x plus 3y equals a -2. Okay, add these two together. You can see that my x terms cancel out, which is what I want. We're always trying to just get one variable, because you can solve for one variable. Here we have 5y, and that equals 10. Divide both sides by 5. 5's cancel, and we get y equals 2. Okay, so in our ordered pair, the y part of it is 2. But now we've got to find out what x is. So we'll put in, we could use our first equation. We have 2x plus 3y. I'm going to put in the 2 for the y. That equals -2. Alright, so 2x plus 6 now equals -2. Subtract 6 from both sides. 2x plus 6 minus 6 equals -2 minus 6. Okay, so we have you can see what happens to the 6's on this side. We get 2x equals, and this was, let me fix that. That's a -6. Okay. 2x equals a -8. Alright, divide both sides by 2. And x equals a -4. So I'm going to stick that up here. So I have the coordinate pair. Oops, a negative. That's a negative. -4. Okay, so the coordinate pair is -4, 2. So now we're going to stick that into both our equations. Make sure it works. So we have 2 times our x is -4 plus 3 times 2, which is our y, and that's going to got to equal a negative 2. Negative 8. 2 times negative 4 is negative 8. 3 times 2 is 6. Negative 8 plus 6. Does that equal negative 2? Yes, it does. Negative 2 equals negative 2. Okay, it works in the first equation. Let's see if I can make room enough here. Okay, we'll try it in the second equation. The second equation was x minus y equals a negative 6. Okay, so let's stick the negative 4 in for x. That's minus whatever y is, which is 2, equals negative 6. Does a negative 4 minus 2 equal negative 6? Yes, it does. Negative 6 equals negative 6. So it works. We're done. There will be a couple aspects of this number 6 problem, so I thought I'd talk about it. So this is my instructions here on this problem. We're translate the problem situation to a system of equations. And then I gave more detailed instructions. I said, first make x equal to one unknown and y to the other. Then the second part then is then you write the two equations with x and y from the information given in the problem. And it says do not solve. But you can use this method to solve a lot of different types of problems, word problems. Okay, so let's read our problem. It's Alice's restaurant had a total of 37 seats. The number of seats in the non-smoking section is 19, more than twice the number of seats in the smoking section. How many seats are in each section? All right, you're going to have to read this a few times. I mean, I had to read it a few times to get a picture in my mind of what they're talking about here. And so first you select what's going to be your unknowns, and your unknowns are the smoking section, how many are in the smoking section, and how many are in the non-smoking section. So we can make x equal to smoking section, and we can make y equal to non-smoking. Doesn't matter which one you make x and which one you make y, just you follow through. Okay, so that's step one. Okay, I'm going to put step one. Okay, step two. Let's figure out the equations. Okay, so now the first thing it tells us in that sentence up above is Alice's restaurant has a total of 37 seats. Okay, so that means that total of smoking and non-smoking make 37. So the first equation is easy. It's x plus y equals 37. And that's our first equation. All right, now the second equation has to come from the rest of it. The number of seats in the non-smoking section is 19, more than twice the number of seats in the smoking section. So we have a relationship between the non-smoking section and the smoking section. So the number of seats in the non-smoking section is 19 more than twice the number of seats in the smoking section. If you think about it, there's not going to be as many in the smoking section. Actually, there are no smoking sections in Connecticut, I don't believe. We used to have. I think it's all non-smoking in restaurants now. But anyway, there wouldn't be as many in the non-smoking section. So you have to keep that in mind. All right, so number of seats in the non-smoking section is 19 more. So non-smoking section is our y, right? Let me underline that. Let's see. The number of seats in the non-smoking section is 19 more than twice the number of seats in the smoking section. Right? That's where our second equation is coming from. The number of seats in the non-smoking section, okay, y equals 19 more than twice the number of seats in the smoking section. Okay, so plus 2 times our smoking section is x. Okay, so there's our two equations. And this, now we have two equations. We could use the substitution method or we could use the elimination to solve this problem. But remember, it says do not solve. This is the hard part. The other part is just kind of automatic. For instance, here we have y equals 19 plus 2x, we could then take that 19 plus 2x, because it equals y, it's going to have to equal y in the other one too. So we just stick that in for y. Then we're going to have, we'd have this. We'd have x plus 19 plus 2x, right, equals 37. And now notice we just have one exponent, the x. And we can solve for x, and then after we have our x, we just stick it in here, and then we'll find our y. But I'm not going to do that now. Bye. Problem number 9. Simplify the expression. Assume that variables represent non-zero numbers. Okay, that's actually only a problem when I mean, if x was 0, then the whole thing is 0, right? That's only a problem if there's x in the denominator. So we don't have any denominators here. Okay, so we have x to the 4th, and that is to the 3rd power, and then x to the 5th. And the best way to do these things, unless you remember the rules, which you should figure out from actually doing a bunch of these, you start remembering the rules. That's really the only way to memorize the rules, is to actually do a bunch of problems. Okay, so I'm going to rewrite it. We have x to the 4th, that's whole thing is to the 3rd power, and that's times x to the 5th. Okay, so x to the 4th is 4 of them, right? 1, 2, 3, 4. And that is to the 3rd power, right? So, and then that is times x to the 5th. So, we can write this part, x to the 4th to the 3rd power, factor it out, that's what this is called. We'll make 4 of them. 1, 2, 3, 4. I have to make my x's smaller. Okay, so 1, 2, 3, 4. Oops, I didn't want 4 in there, did I? 3 is to the 3rd power. Okay. Okay, so now we hear there is x to the 4th 3 times, and that is times x to the 5th, which would be 5 of them. 2, 3, 4, 5. This is the easiest way to do it, and after you do enough of these, you'll start remembering what the rule is. Okay, so let's count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. X to the 17th power. That was pretty easy. If you remember the rule, then you look at you see this and you realize, well, there's x to the 4th, and that's 3 of them. So 4 times 3 is 12. And the next to the 5th, there's 5 of them. So we have 12 of them, 5 of them, 5 plus 12 is 17. So we end up with the same answer if you remember the rules. But you don't need to. Number 11. We have 3y over 2. All of that is to the 3rd power. Okay, I'll rewrite it. 3y over 2 to the 3rd power. So that gives us 3 of them, right? Each one, I'm going to just change color here. 3y over 2, 3y over 2, 3y over 2. Okay, let's multiply those 3's. 3 times 3 is 27, 3 times 3 is 9, times 3 is 27. Okay, so we've got 27. Y times y times y is y to the 3rd power. 2 times 2 times 2 is 8. Pretty simple. If you wanted to do it by using the rules, okay, so we're going to end up with 3, I can't write it up there. Too high. Let me try again. We get 3 to the 3rd power, y to the 3rd power, over 2 to the 3rd power, because each of these is actually to the 1 power. But I think the easiest way to do it is to factor them out like I did before. See, 3 to the 3rd is 27, y to the 3rd power is y to the 3rd power, 2 to the 3rd power is 8. So we see we get the same answer. This problem, even though I've tried to beat this into your heads, that when we add or subtract polynomials, we do not change the exponents. All we're doing when we add and subtract is we are combining like terms. So this is a situation where we're combining like terms. To give you an example, before I do that problem, let's say I had 2x cubed plus 5x cubed, or x to the third power. Okay? So here we have 2 of them, here we have 5 of them. If we add them together, we have 7x cubes. That's all. You could say, okay, well, it's just like if we had 2 boxes plus 5 boxes. You don't know what's in the box, but you know you got boxes. Both the boxes are supposedly the exact same thing. So we'd get 7 boxes. This is the combining of like terms. It's different, a whole different thing if you've got 2x cubed times 5x cubed. 2x cubed times 5x cubed, well, we multiply the numbers, right? The 2 and the 5, and we get 10. We multiply these. X cubed times x cubed, that'll give us 1, 2, 3, and then there's 1, 2, 3, times themselves. It gives us 6 times themselves. The definition for a number times itself one time, or 2 times itself, is that thing to the second power. This is 6 times itself, so it's this thing to the 6th power. So that would be x to the 6th. There's a big difference between the two. You'll get completely the wrong answer. If you add exponents when you're adding or subtracting, you're going to get the wrong answer. You only add or subtract or do something with the exponents when you're multiplying or dividing, and that's that. So if we do this problem, which is in the first parentheses, there's a negative 5x to the 4th plus 5x squared, and that's minus everything in the second one, which is a negative 10x to the 4th minus 9x to the second power. Now, this negative, the best way to do a subtraction is to assume that that negative is a negative 1 multiplied times both of those, and becomes like a distribution thing. Either that, or the other way you can think about it is this negative here negates both of these, whatever they are. If they're positive, they become negative. If they're negative, they become positive. See, once you've taken care of that, then it's an addition problem. So we have negative 5x to the 4th power plus 5x to the 2nd power. And you notice we can't combine those two because they're two different things. We don't know what x is. We cannot combine something with different powers, different bases. On this next one, all right, we have minus a negative 10x to the 4th power minus 9x to the 2nd power. Okay, so like I said before, we're going to negate everything in here. So a negative of negative 10x to the 4th is a positive. A negative 9x squared is positive, and that becomes addition now. So now all we're doing is combining like terms. So now we're going to look for like terms. Our like terms are these two. We can combine those two because they both have x to the 4th powers. So a negative 5x to the 4th power combined with a positive 10x to the 4th power is a positive 5x to the 4th power. All right, now we're going to combine these two. These are the other two like terms, 5x squared and 9x squared. So not only we don't have just 5 and 9, we have 5 plus 9, which is 14 of them. We have plus, let me do it black, plus 14x squared. We just have 14 of them now. Notice I didn't add the exponents. Do not add the exponents when we're adding and subtracting these things. Problem 14 from the Chapter 4-5 test. Or actually in the future it's going to be a review. Okay, negative 2x to the 7th power times the negative 11x to the 4th plus 8. Okay, this is just a distribution problem. We're going to distribute this one over this, and we're going to distribute it over that one. Okay, so it's like we're multiplying those two things. You could do them separately. If this is confusing for you, you know what this equals. This distribution becomes a negative 2x to the 7th times a negative 11x to the 4th. And that's going to be in addition to a negative 2x to the 7th times 8. Okay, so then solve those individually. A negative 2 will do the numbers times the numbers, right? Negative 2 times a negative 11 is 22. Okay, x to the 7th times x to the 4th. So we have 7 of them here. We have 4 of them here. We could, if there's any confusion, you can factor it out. Make 7 of them. 1, 2, 3, 4, 5, 6, 7. And we make 4 of them. 1, 2, 3, 4. And then we count them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So 22x to the 11th power. Or, if you notice, x to the 7th, the 7 plus the 4 gives us 11. Alright, second part of this problem. We have 2x to the 7th times 8. We multiply the numbers times the numbers. So that gives us a negative 16. And then there's no exponent. If this had an exponent, it would be x to the 0 power, which equals 1, right? So this x to the 7th, we just keep the x to the 7th. Can't just get rid of it because it's not there. And you notice we'd have 7 of these x's, and then over here we have none. No x's, right? So 7 plus 0 is 7. So our answer is 22x to the 11th minus 16x to the 7th. Number 15. First parenthesis has x plus 5. Second parenthesis has x squared minus x plus 7. Okay, this is really a distribution problem too. The only thing is we've got 2 things in the first part to distribute over 3 things in the second part. Include that negative. Okay, we'll start with our x. We're going to distribute the x over x squared and over the negative x and over the 7. Okay, so if you need to, write these all separate. We could write it like this. We'll go x times x squared, and that's going to be plus x times a negative x plus x times 7. And then we're going to do the second part, which is the 5. We're going to go 5 times all 3 of them. 5 times x squared, 5 times the negative x, and 5 times the 7. So this would be plus 5 times, I'll write it down here, 5 times x squared, and that's plus 5 times a negative x plus 5 times 7. Okay, so now let's write the answers to each one of these, and then we're going to combine like terms if we have them. So x times, first one we'll do, x times x squared is x to the 3rd power. That's going to be plus x times a negative x, which would be a negative x squared. There's 2 of them, right? Then we have x times 7, so that would be 7x. We'd like to put the number first, right? Okay, the next one is 5 times x squared, so I'll put it down here. Okay, so that would be 5x squared, because there's a number 1 is 1x squared, so 5 times the 1 is 5, 5x squared. Okay, then we've got 5 times a negative x, which would be a negative 5x, and then 5 times 7, 35. Okay, so now let's just put that all together in one long row. We've got x to the third power minus x squared plus 7x plus 5x squared minus 5x plus 35. So it's kind of turns into a kind of a big problem, but it's not hard. There's nothing hard about it. Now we're going to look for the things that are the same. Okay, so I've got an x squared term here and an x squared term here, and I've got an x term here and an x term here. So I'll be combining those two, and I'm just going to keep everything else, which is just added to it. I'll say, okay, so I'll keep my x to the third power. All right, negative x squared plus 5x squared would be 4x squared. Okay, positive 7x combined with a negative 5x gives us 2x, and then we just keep our 35. There's our answer. X cubed plus 4x squared plus 2x plus 35. If you can do this in your head, you'll save yourself a little bit of trouble. Remember, we're going to distribute the x over this, and the x over this, and over this. Okay, so we'll start that first. X times x squared is x to the third power. X times a negative x is a negative x squared. X times 7 is a positive 7x. All right, then we're going to distribute the 5 over all three. 5 times x squared is 5x squared. 5 times a negative x is a negative 5x. 5 times 7 is 35. And again, I'm going to combine like terms. I'll combine that one with that one, and this one with this one, which gives us, as we got before, x to the third power plus 4x squared plus 2x plus 35. All right, number 16, 13 plus m times 13 minus m. Again, we just have it's a distribution problem. We're going to take the 13 times the 13 and the 13 times the negative m. And then we're going to take the m times the 13 and the m times the negative m. Doing one at a time. Okay, so 13 times 13, I think, is 169. 13 times a negative m would be a negative 13m. Okay, m times 13 is a positive 13m. M times a negative m is a negative m the second power, or m squared. Okay, so now notice these two middle terms cancel themselves out, and so we get 169 minus m squared. Now, if you notice this in the beginning, that this problem here with this times this becomes the difference of two squares, 169 and m. The difference is a subtraction between the two squares, and the first one is a positive, and the second one has a positive aspect and a negative aspect. See, so this is what they become, but you don't have to remember that special rule. You can just multiply it out. It takes just a couple seconds longer. Okay, either way, you're going to get 169 minus m squared. 17, z to the negative 9 divided by z to the negative 4. Okay, so if you remember, I told you the shortcut to this, z to the negative 9 over z to the negative 4. The shortcut to this, the easiest way to remember what to do is you put the negative, you take the number, because a negative exponent means that same number, z, would be the reciprocal if it was positive. It'd be reciprocal. So this one will end up under here, it will be positive. And if this one, to become positive, has to go up here. That's the easy way to do this. So we're just going to do that. We're going to put the z to the 4th power on top and the z to the 9th power underneath. Okay, so now once we have that, factor the thing out. See how many z's you have. On top we have 4 of them. 1, 2, 3, 4. And that's over 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we know we can cancel z divided by z is 1, so we can cancel out as many that we have both top and bottom. I'm going to change color for this. 2, 3, 4. Okay, but we still have a 1 on top. So we'll put a 1 on top. Okay, how many do we have left? 1, 2, 3, 4, 5. Z to the 5th power. That's our answer. The other way to do it with the rule of subtraction, you can subtract the exponents if they have the same bases. When you're dividing, this would become z to the negative 9 over z to the negative 4. But I think it's easier to do with the factoring out myself. We can do it this way. Okay, so it would be equals z to the negative 9 minus a negative 4. A minus of a minus is a positive, so that becomes z to the negative 5, right? Positive 5 plus a negative 9 is negative 5. But again, that's to make this positive has to become the reciprocal, so we put it 1 over z to the 5th. Notice we get the same answer. And I would factor it out. That's the easiest way. You'll be sure you got the right answer then. Okay, we're at scientific notation now. So convert to scientific notation. I'm going to do 2 of these. I'm going to do one from a big decimal to one from a big number. And we're both going to go into scientific notation. Scientific notation is some number, let's call it b, and that's not the y-intercept, it's just a number. We'll say we'll call it b. And we'll say that that's times 10 to some power. 10 to some power, like 10 to the 1st power is 10, 10 to the 2nd power is 100, 10 to the 3rd power is 1,000, and so on. You notice the 3 and the number of zeros. And then there's the other way, going into decimals. We have 10, you can say, well, 10 to the 0 equals 1, 10 to the negative 1 equals 1 over 10, 10 to the, or 0.1, 10 to the negative 2 equals 1 over 100, or 0.01, 10 to the negative 3 equals 1 over 1,000, or 0.001, which is 1,000th. Now notice in this case that the number of the negative power of 10 has the same number of decimal points, decimal places, same number of decimal places. Here's 2, notice 2 decimal places. To the negative 1, 1 decimal place, 0.1, 0.1, okay? So this is a good thing to remember. Okay, so if we're going to do this number, 0.0000006900019, the b number, the number that we're multiplying times the power of 10, has to be between 1 and 10, not including 10. It's got to be a single digit number. Okay, so we're going to find that, which is right here. Right here. We're going to be moving the decimal point to this spot right here. Okay, but we'll start at our decimal point, and we'll see how many zeros we're taking away, really, or how many decimal places we're taking away. It's 1, 2, 3, 4, 5, 6, 7. We're taking away 7 decimal places. Our answer will be 6.9, and then we'll keep whatever's left here, what other numbers are. But it's 6.9. Notice 6.9 is between 1 and 10, not including 10. Okay, And how many decimal places? And this is going to be times 10, and it's going to be to the negative power. Because it's a decimal, we're making the decimal look like a larger number, right? But it's still a decimal, so it's got to be a negative. If you're changing a decimal to a scientific notation, you're going to change it into a power of 10 that's a negative. All right, so let's just figure out how many places we've got here. 1, 2, 3, 4, 5, 6, 7. Okay, 7. So it would be times 10 to the negative 7. All right, let's do another number. Let's change 7,450,000 into scientific notation. Okay, again, we're going to figure out where we want our decimal point. Our decimal point's got to be here, because the number's got to be between 1 and 10, not including 10, right? So, starting at where the decimal point is on this number, we'll see how many decimal places or how many zeros we're removing. So it's 1, 2, 3, 4, 5, 6. There's 6 of them. So it'll be 10 to the 6th power that we're taking off this number. So we rewrite it 7.45 times 10 to the 6th. That's it. Number 20, it says write the expression in standard form. That's typical numbers, right? So we've got 7.15, 7 and 15 hundredths, times 10 to the 3rd power. So we're going to be putting the zeros back into this. We're going to be putting the places back in. So 10 to the 3rd power is 1,000, right? 3 zeros. So we start with our decimal point again. We have 7.15, and we're going to add 3 of them back in. 1, 2, 3. So this is where our new decimal point is. We're going to have to stick a 0 here in this little valley. So the answer is 7,150. Notice if we went backwards, decimal point here, we go 1, 2, 3. We'd make the number look smaller, but then we'd have to put times 10 to the 3rd power. Okay, division problem. Again, this is like distribution in that, you see we have 10x to the 8th power minus 30x to the 5th power, and that whole thing is divided by negative 5x to the 8th power. So we have to take that negative 5 to the 8th power, and we've got to divide it into both of those. So I think the easiest way to do it would be to rewrite this problem as 2 divisions. We'll divide the negative 5x to the 8th power into 10x to the 8th power, and we'll divide it into the negative 30x to the 5th power. We'll do it separately. Okay, we've got 10x to the 8th power divided by a negative 5x to the 8th power. Okay, and then we'll do separately, we'll do negative 30x to the 5th power divided by a negative 5x to the 8th power. Okay, and then we will just add those together when we're done, whatever the answers are. Alright, so let's do the one on the left first. 10x to the 8th. Now notice that both of these are the same. If both of those are the same, when they divide, it's going to be 1. Okay, but the numbers aren't the same. 10 divided by negative 5 is a negative 2. So the answer is a negative 2, or negative 2 times 1. So all we need is that negative 2. All right, we'll do the other one. Okay, negative 5 into 30 is 6. See, we divide the numbers. Just like when we're multiplying, we multiply the numbers first. All right, now to do the exponents is another story, right? Because we don't have the same on top as we do on the bottom. As a matter of fact, there are more on the bottom too. So to eliminate confusion, let's multiply the 6 times what we have left. X, 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 x. There's our x to the 5th. And that's over x to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so now let's cancel out all the 1s. Okay, we have 3 left on the bottom. So we're going to have 1 on the top. So the 6 will go times that 1. So will give us a negative 2 plus 6 over x to the 3rd power. Let me do that again. I'll do it slightly different. Okay, we've got, but I'm going to still do it, divide them both at the same time. I mean, both separately. 10x to the 8th divided by a negative 5, 8 to the, x to the 8th again. Okay, and then over here we have negative 30x to the 5th divided by a negative 5x to the 8th. Okay, so now I'm going to separate these. We'll end up adding these together, whatever's left. And of course you still can't combine unlike terms when we're adding. Keep that in mind. Can't combine this. We're not going to get one answer out of this because we have different kinds of exponents in the answer. Alright, so we'll separate this out. We've got 10, and that's times x. We could put 8 of them, I guess. 1, 2, 3, 4, 5, 6, 7, 8. And then we have a negative 5. We could even make these separate like this. Okay. Okay, will this cancel out each of these? See? So you just get 1. So all we have left here is 10 divided by negative 5, which is a negative 2. Okay. Plus whatever we get over here. So let's do the same thing over here. We've got a negative 30. That's times x to the 5th. 1, 2, 3, 4, 5. And that's over negative 5 times 1, 2, 3, 4, 5. Alright. Again, let's cancel out the x's. So we have 3 left there. Negative 30 divided by 5 is 6. And that's times whatever we have left here. Times 1 on top, because all those divisions, x into x is 1. So we're going to have when 1 times 1 times 1 times 1 is still 1. Okay, we cancel all those out. We have x to the 3rd power on the bottom. X times x times x is x to the 3rd power. Okay, so we can rewrite this. If we made, we put the 6 over 1, you notice the 6 goes times the 1. We get a 6. And on the bottom is x to the 3rd. And of course, let's put in our 2. So negative 2 plus 6 over x to the 3rd.